We are talking about congruent triangles, and we want to talk about marking information on diagrams. So the first thing we have given, uh, angle A is congruent to angle C. So angle A, I'll put 2 marks here, is congruent to angle C, put 2 congruent marks there. And then it says line segment BE. So line segment BE, I'll put 3 on this one, is congruent to line segment BD. So that's the given information. There's one more piece of information that we can draw on here and show that they're congruent, and that is we can talk about the vertical angle. And in this case, the vertical angle says that angle ABE, and I can put, let's just put 1 here. Angle ABE is congruent to angle CBD. I'll just put 1 there. And that's just because we know that vertical angles are congruent. Then we will get example 3, and we'll have to mark all these, and it says line segment AB, so there's AB, is perpendicular to BC. So perpendicular says I'm going to mark it with that mark there. And line segment CD is perpendicular to line segment DA, so I'm going to mark that as perpendicular. So we did these 2 already. And then it says line segment AD right there. So I'm going to put AD, put 3 there, is congruent to line segment CB. So I'm going to put 3 there. There's one more piece of information that we can say, and that is we can say that, so this is going to be triangle CBA, and that would be congruent to ADC. So we can say that line segment CA is congruent. So line segment, so we get ADC or CAD, that's going to be congruent to ACB. Let's say that again. Triangle ADC is congruent to CBA. So that's going to be line segment AC, and that is by the symmetric property. Because it's basically the same line segment, just written in a different order. I guess we can write the angles over here that we were talking about for example 2. So the angles that we're talking about are angle ABE is congruent. So A matches up with C, so I have to name it in the same order. And I can tell that it matches up because they both have the 2 congruent marks. So ABE is congruent to CBD. We can look at example 4, and it says angle B, put 3 here, is congruent to angle D. So we got 3 and 3. And then it says angle BAC, so BAC, let's put 2 there, is congruent to DCA. So we put 2 here. So some other information that we can say that line segment AC is congruent. So if we're going to say so this is going to be no mark, green mark, red mark, is congruent to no mark, green mark, red mark. So that's going to be congruent to CA. If you look at that again one more time. So if we start at A, so we said A, so no mark to green mark to red mark. So it says AC, no mark to green mark. No mark to green mark is CA. And again, because it's AC, line segment AC is congruent to CA, that is going to, the reason that we can say that is symmetric. Symmetric property of congruence, but if you said just symmetric, that'd be fine. If we're looking at the next one, example 5, we have angle B is congruent to angle D. And it says BC, so I'll put one triangle there. BC is parallel to DA. So those two lines are parallel. So if we have parallel lines that are cut by a transversal, so we have two parallel lines that are cut by a transversal, we should know some things about that. And on this side, we have this angle over here. And we already used 2, so I'll put 3. So that's one parallel line cut by a transversal. We should know something about this angle right here is also congruent. So angle DAC is congruent. Now, it's, we can see that it's going to be this angle here. We don't know if we should say A or B first. We started with D, which has the 2 congruent marks, and then go to the angle, so DAC. Now we're going to do the same thing. We're going to start with the 2 congruent marks, so 2 to 3 to 0, 2 to 3 to 0, so BCA. Angle BCA. 2, 3, 0, 2, 3, 0. We have to go in that same order. And the reason that we can say that is because of alternate interior angles. Then we have 2 more to talk about. Again, we have parallel lines. So it says AE, line segment AE. So I'm going to put the parallel line mark on there. Is parallel to DC. And then it says B is the midpoint of line segment AD. So B is the midpoint of line segment AD. So if that's the midpoint, then eventually we'll be able to say that those are congruent. And again, we have 2 parallel lines, and this time we're cut by 2 transversals. So we can say a few more things. We can say that this parallel line cut by a transversal. I'm going to put 2 marks here. Here's the transversal and the other parallel line. So here's that other angle that we're talking about. And again, that's alternate interior angles. In this one, we don't have to name it with 3 different things because there really is only one angle that can be there. So we can say angle A is congruent to angle D. Another option that we can take a look at, again, we have 2 parallel lines, and it's cut by a transversal. So this time I'm going to use just 1. And that is going to be angle E is congruent to angle C. Angle E is congruent to angle C. And I guess I forgot to write my congruent sign on this bottom one here. And so in this case, the reason that we can do that, the same reason, is because of alternate interior angles. Alternate interior angles. So we have 2 examples where we're given parallel lines. And in those parallel lines, because of those parallel lines, we are told that those parallel lines ended up giving us a bunch of congruent angles because of our translation rules. So we have parallel lines cut by a transversal. Our alternate interior angles are congruent, and that's going to happen a lot. So here's a note. Anytime we have parallel lines, they give us congruent angles. So we want to make sure if we given parallel lines, we should be thinking congruent angles.